In the sketch alongside, we have KM. Let's check KM. KM is this one.
Yes.
It's parallel to
Okay.
PQ. Okay, can highlight the parallel lines. We need them.
What?
We have this one, which is parallel to this one.
Yes.
And then we have prop. With so meaning which we are talking about this side here, which is going to be in proportion with this side here, because of the parallel lines.
Yes.
Do we have another one using this
Yes,
parallel lines?
we have QR and RL.
You mean the parallel lines? No, I meant according to the parallel lines. We are done.
Yeah, we are
Okay.
done. We need to know others.
Let's check others. So we also told which we have KQ, which is this one. It's parallel to this one.
Yes.
If we start from here and then we go there, it gives us this side. It gives us this side.
Yes.
Is in prop with this one.
Yes.
So if I start from there and go there. Okay, if I start from here, just give us a triangle. If I start from here.
No.
If I start from here, and then I move in this direction. There's no any other one.
Yeah.
These are the ones that we have.
We have two triangles.
We have two triangles
That
that
are in proportion.
which we can use prop on there. Okay, so we have KP. KP it's 5x.
Yes.
And then we have PL, which is 7x.
Yes.
Oh, the values.
Yeah.
Yes.
Like using the
KP.
letters too.
PL is 5:7. Okay. So we can start by saying if we compare this one and this one, it means we can tell them which we have KP all over PL.
Yes.
This is going to be equaling to QR, which is this part all over this one,
Outline.
which is RL,
Yes.
which is going to be equaling to 5 all over 7. And then this is a reason it's prop theorem. Because we have K
Q.
parallel to PR.
Yes.
This one, it makes sense. You see?
Yes.
We haven't started with the question, we're just summarizing everything that we have. So you can come and update and say, okay, but it means which this one can be, it can be, let me erase this so that I can show you. So this is 5K is to 7K. And sometimes it helps to also do it from here to here. This one is 5 plus, gives us what, 12?
Yeah.
12K. It was 5 plus. Because sometimes we take this one for granted. I think let's put it there so that just in case it comes, just in case you need it. So we can also tell them what from here to here is 12x. Okay. Now that we've used that one, what else can we say? I think we had other parallel lines.
Yes.
Let's go to those ones. It was green. It was this one. So we had this part and this part. So this part and this part, they're in proportion. So how will we write that one? We can write it this way. We can say we have PK again, PK or KP. All over, I got KP, this one. All over PL. And then we say this is going to be equaling to
MQ.
MQ, all over
QN.
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 Starting from here to here.
Yes.
Okay. And then this is going to be equaling to 5 is to 7. Okay. This again, it's a line parallel one side of a triangle. Okay.
Yes.
Okay. We can come and update and say, but here we have. Okay, let's use the black. So starting from here to here, we say this is 7p. Oh, it's 5p. But from there to there, it gives us 7p. So that's what we have. I think we've highlighted everything that we have and everything that we might need. Are we good, guys, so far? using the given information and
Yes.
also utilizing the prop theorem. We are fine with that one. Eh? Okay, let's go to what they're asking us then now. From what they're asking us, I will erase the parallel lines, but I need the prop lines. I won't erase those ones. So the props, I will leave them like this. Okay. Now, let's go and say we have PRL. Let's check PRL. We have P, we have R, we have L, like this. This one. And then we want to compare it with who? We want to compare it with, it's K, QL.
Yes.
It's K, it's Q, it's L, this one. Oh. They're between parallel lines, was this? Okay.
Yes.
We have these ones which are between two parallel lines. Ne? So we have
Yes.
this one and the green one which are between two parallel lines. What have we learned about two triangles that are between parallel lines? Now, I want us to approach this thing here. Which, how will we approach it then? We'll say something like this. We'll tell them, which, okay. We are going to have this being given as number one. Base number one that we have, Anish, this thing here is going to be given as PL all squared. This is going to be given as PL all squared. So I'm going to say that it's PL all over. The other one, it's LK. LK all squared. Yeah? And then when they ask us why are we saying it, we need to give them a reason. I agree this one, it was not there. We know it from the fact that they have a common angle and then they are also between parallel lines. So how would I write this? That's the important thing. I was already given this part. When KP and PL I was given. So I'm using things that I was already given. So there's no need for me to use prop theorem. So I'm just saying which if you're answering Khotso, because this one is given, this one is also given. You can go directly and say, this thing here can be written this way.
You don't need to do the prop.
Yeah. We don't need the prop theorem. For this one, for number one, we don't need the prop theorem.
Yes.
Okay, I wanted to say copy. And then I want to write this here. Okay. Okay, we want to know what is going to be the answer for this one, specifically for this one. So the answer for this one, we're going to say that it's going to be equaling to, we say it's PL,
Yes.
all over. We said what? KL.
Yeah, KL squared. It's PL over KL, yes.
All over KL.
Yes.
It's PL all over KL all squared,
Yes.
And then we need to give them a reason because this was not there. We need to give them a reason why are we saying this with confidence. So we say we're going to use the fact that we have a common angle, and then we also have what? Parallel lines. Let me use parallel lines. This one, parallel lines. And then from the onwards, we can go straight to the answer. What is going to be our answer for this thing here?
Our answer is 49 all over 144.
Yes.
What we get? I agree we have, or you say we have
49
7 all over
12.
all over 12. Okay, 7 all over 12 all square. Yeah, so we'll write. Thank you, Rakut. You say it's 7.
Yes, over 12.
All over 12 all square. Then you say you get what? 49
Over
144.
144.
Can it be simplified?
no.
It can be simplified any further. Okay. Next we go to the next one. Okay. I wish which has this thing I can do it all with everything's visible once because this thing of going up and down. Okay, let's go to the next one. What is happening with the next one? We just have to highlight it and check what is it that is giving us. So I'm going to erase this one. We're done with this one. Right?
Yes.
Let's go to number B. On number B, we have KPQ. No? Let's highlight KPQ. We have K, we have P, we have Q. This one here. No?
Yes.
Okay. It goes with who? KLQ. No?
Yes.
It goes with KL. Q, like this.
Yes.
Okay, but this one and this one, they are not between parallel lines, but they have a common vertex here. No? So it means which we can construct a height. So this one is going to be, the green one here, it can be the obtuse angle that we usually speak about. No? And then this one here is going to be the acute triangle. So if we construct a common vertex here, it's going to be here. This one, we're going to construct our height here. So our height is going to look upside down. So what do they have this thing here? They have a common height, like they have the same height.
Yes.
So if we're doing this one, how would we do it then? We are going to say this thing here. I'm first going to write it here so that we remember. So this thing here is going to be given as the base of this one is P. It's KP, this one. The red one is KP, the base. No? So we have K, we have P all over. This one here, the base, it's LK.
LQ.
LK, not LQ. What?
Yeah, LK, sorry.
Yes. So now that we're going to do it then, how would we do it then? This one we're still, we haven't used the prop theorem because we're still using this thing. It was given LQ and these ones they were given. You know? So I'm still using those things that were given. So how would this one look like? Let's check. So we'll write something like this. We'll say we have, okay, for number 2. So we want this one. So we agree to say which is going to be written as, what did we say? It's going to be written as what?
Yes.
It's KP. Ne?
Yes, over K.
It's KP all over
KL.
KL. Now, what is the reason with this one? This one, we're going to tell them that they have the same height.
Right.
All the
But
common
now-
vertex are wrong again.
Yeah.
All the common vertex are wrong again.
No, not necessarily. They don't have it, like the common vertex is not the one that is making them to have.
Oh, they must
So
have
yeah,
different-
it's because they have the same height. That is why they have, yeah.
So-
Because you see other reasons also, it's like, yes, the reason is, but it doesn't make us to be good. So the reason why we had our basis in ratio, yeah, but it's because of the common height. If the basis, they don't have the, if these two triangles, they don't have the same height, then they are not going to, their bases are not going to be in proportion. So what do we have SKP? It's 7. It's 5. It's what?
Right.
5
It's 5
over
all over 12.
Yes.
yes.
Let's check. So it's 5 is this one.
Yes.
All over what? All over 12. So it's still nothing special. Okay, we are jumping now to the next one. Erase this part that we no longer need. Okay.
Mr. Hogan, but you can pen for us. Is that possible?
Is it possible? I don't know. Check. KQL.
Okay.
What is it? It's K. It's Q.
And then
It's L. This big one.
Yes.
KQL. Okay, sharp. It goes with who?
AQM.
Yes.
It goes with
K
K.
Q L.
QM like this.
Yes.
Okay. Again, these two triangles, yeah, when they have a common vertex here, which is going to be K.
Yes.
They're not between parallel lines, but we can make a height like this. So this one is going to be the obtuse, this one is going to be the acute. So what is going to be this? Let's check what is the base of the top one. The base of the, once you create a height, that's when you're choosing your base. So because I've created the height, it means which is the first one, the one on top, which is KQL, which is the red one. This one is going to be equaling to QL all over. the bottom one, the base is MQ. MQ. But now look at this one here. This one here, this thing here, we don't have this information which is below here. Since we don't have this information which is below here, we need the prop theorem. So I'm going to write this prop theorem. I need this prop theorem. I also need this prop theorem. For me to do this question properly, I can't do it without this because I agree this one. You see, when I was speaking about this, I said this one, it was given. You know? So I was using these things that were given. I didn't need to code prop theorem. All these things that are below here, they were not there original. All these things, they were not there.
Yes.
How did they get there? They got there because we use the prop theorem. So now we need on our number 3. When we write number 3, we need to start there. We can't just go to number 3. We're going to start by saying, okay, but remember, how did you get to the answer? Exactly the way we did. We started here. And the nicest thing, which once you have it in your notes, I'm sure you have this. You simply plug it here. And then you take the other one, you plug it here, and then you're good to go. That's our number 3. So the way we'll do number 3 will have more marks here, and you'll see. So if we do number 3, we're going to start by telling them, okay, KP all over PL is going to be R all over RL, if I'm not mistaken, which is going to be 5 all over 7. And then
7.
the line parallel one side. Okay, the other one that I have is this one.
Yes.
Also, I'm going to tell them with okay, KP all over PL is going to be equal to MQ all over QL, which is going to be equal to 5 all over 7. Again, I'm going to use it a line parallel one side. So these things I have them now. Now, as soon as I have this, then I can go back to my area. Then I can do the area thing now. It's just a formality, this thing, because we know the basis that we're going to use. So I can then go and say, okay, but look at this. So we want number 3. Ne? Okay, sharp. Yeah. So what is this thing here, basically? The way we said it, we said this is going to be, which base did we use? We said we are going to use base QL, that's number 1. So we write QL all over MQ. So we say this is going to be given as QL all over MQ. And then what is the reason why we are saying this? We are saying this because they have what? The same height. That's why we are saying this, because they have the same height. But now we know what is QL. QL we are saying is 12.
Yes.
What is MQ?
5.
It's 5. So it means this is going to be 5 all over what? All over?
So the variables is at the end of one. We just take the values count. 5p and then
No. If they're not the same, then you say we don't have the same variables.
You don't have
It's 7.
this 12k. This is 5.
Okay, let's write them that way. You're correct.
No, it's 7, that one.
Hmm?
It's 7. QL is 7. 7
Q-
B.
oh,
And it's 12. It's 12. You wrote 7 there by mistake.
I wrote what?
7. And if you go to the graph, it's 12.
No, in terms of P.
Mr. If you're writing in terms
In
of
terms of what?
In terms of
QL is going to
P.
be 7.
So in terms of P, it's 5 is to 7P.
Yes.
But in terms of K, it's something else, it's 12. So, but we don't want to relate these two because we already have it in terms of P, So let's write it in terms of P.
Yeah, 7 over 5.
So let's fix that. It means this is going to be equaling to, okay, it's 7 all over 5. Ne?
Yes. Or we write it in terms of.
Yeah, we have it in terms, I think we have it in terms of many variables here. But what Rapela was saying is very important because you see, I just said 5 is to 12. Not writing the variables. I was supposed to write it with the variables so that I would have seen which there's a mistake there.
Yes.
So that I would have related the P and the K if it needs to be. But there was no need for that because there's a P here and then there's also the P there. Now we've used the prop theorem. Let's jump to number 4.
Oh.
Yeah. With number 4, let's check what is it that we have. We have PRL. PRL, I like to start with it. We have P.
No.
PRL, this one here.
Yes.
And then we want our PRL to go with who?
With KQM.
With
KQM, the green one.
KQM, this one.
Yes.
Yeah, you can see them. They don't have any relation whatsoever, this triangle.
Yes.
No common vertex, not between two parallel lines. And this.
Yes.
Yeah, this is the one that we are talking about. Uguchi, you can see these two people.
Yes.
The other one is that side, the other one is that side. But what we then try to check is that from our friends above, can we borrow someone?
Yes.
The one of KPL, this one, you see this one, it also appears here. So this thing and this
Yes.
identical. And then if we check the other one, it's
QL.
it's KQL.
Yes, KQL. With the number 3.
Yeah, we want KMQ, this one, KMQ.
Yeah.
Where else will we get KMQ is?
Number 3, because literally KQL. Yeah.
But we can also have KQL then.
Yes.
So that's how we're going to try to relate them. We're going to be using these people to try to get this K. Gara is what? It's K. It's KQM.
Yes.
Okay, let me write it here. This one. I want it to be visible. We're not doing it. But already we have some information. So what do we have? We have excuse me, we have the area. We have the area of triangle PRL, né? All over the area of
KQL.
K.
Yeah, KQL.
So we have the area of triangle KQL, this one.
Yes.
And then we said this thing can be given, I think it was
5.
no, this one. We're squaring.
Yeah.
No, it was not 5.
It's 49 over 144.
It's 49 all over
144.
144. Ne? Meaning we try area of triangle PRL is going, agree if we cross multiply. We take this percent here. So we have the area of triangle KQL. This one we take it and we put it there. Okay, but now we are going to try to get someone on KQL now. Who can we get who has KQL? This one. This one is KQL, man. But Uno at the same time Uno KQM, man. So we are going to use that one. So who's that person? We are saying we're taking this one. Number 3. It has KQL. That is why we are taking it.
Yes, yes.
So I'm going to say the area. So the area of KQL, because we already know what is this QL. QL we call it as what?
Here we get it as 7.
This one is 7.
Yes.
This one is what?
5.
7 all over 5.
Yes.
So it means go to the area of triangle KQL is going to be equaling to 7 all over 5.
Yes.
Multiplied by the area
Of KQM.
of
KQM.
KQM, like this. Okay, then we can go and sub. Who do we sub? We say, but
You know the area of KQ.
yeah,
We can equate
we can equate.
No,
No,
number
this is
9 AQL.
I'm sure this is KQL.
Yes.
So instead of KQL here, we can come and put which we have. Let me write it in the way I wrote it. The area of triangle PRL is going to be equaling to 49, 144 multiplied by this whole thing.
7 over 5.
It was black. It's 7 all over 5. The area of KQL, like this. What did you get for if you simplify this? Simplify it.
343 over 720.
343 all over.
720.
You can't simplify it.
No.
Then this is going to be the area
Yeah, 343 all over
of
70.
PRL. It looks like April to me. Every time when I read it, it is April.
343 over 720.
All over area
Divided.
triangle KQL QM. I think we're done, guys.
Number 5.
We still have number 5.
Give the last-
So far, so good.